So I've done some of the work. That's just kind of drudgery, just because, just to save some time. I'm just going to jump into these. The first three problems on our review, the last part of the Chapter 6 review, give me an equation, a function that's going to graph to a parabola. We're supposed to identify the vertex, the axis of symmetry, make a table of values, sketch a graph, state where the vertex is a maximum or minimum point, and state the maximum or minimum value. Exactly what we did for every problem in, I think it was section 6.3. The key is being able to get started. In problem 13, there's only a single x squared term. There's not both an x squared and an x to the first power term. And there's no parentheses. When these two characteristics, when a problem has those characteristics, you're going to put 0 in the middle of my x column. If there wasn't a parentheses and there was both an x squared and an x to the first power term, I'd have to use the negative b over 2a formula. And if there was a parentheses, I'd have to change a sign. But since there's not a parentheses and there's not both an x squared and an x term, I put 0 in the middle of my x column. I get bigger and smaller to fill up my x's. And then for each y, I used my calculator. The first number in my x column was -2, and I just did this. I put -2 in for x. So I said -2 and then parentheses -2 squared plus 5 to get my first y of -3. And then I did the same thing with -1. I did -2 times -1 squared plus 5 to get my y of 3. And then -2 times 0 squared plus 5 to get my y of 5. So I wrote down what you would do by hand, but I'm just going to get the y's on my calculator. And then after I get these points, I graph them on my, using a software. So I plotted the points, all the points even. I plotted the point 0.5, the point 1.3, the point 2, -3. Every single point that's in this table I showed on the graph. So this is my making a table of values, that's that. Sketching the function, that's that. Now I'm going to identify the vertex. Always, 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 when I create my parabola tables, I always make the vertex dead center of my table. So you could see it on the graph, I could see it from the table. I wrote here my vertex is 0.5. So that's identifying the vertex. And then it says identify the axis of symmetry. The axis of symmetry is a vertical line that cuts the parabola into equal halves. So this line that I just drew in is the axis of symmetry. And an axis of symmetry always only has an x in its equation because vertical lines have x's but not y's. And this vertical line goes through the vertex, and the x coordinate of the vertex is 0, so the axis of symmetry should be x equal to 0. If the parabola is upside down, the vertex is a maximum point, and that's going to be the next thing. So I identify the vertex, identify the axis of symmetry, and then I need to say whether the vertex is a maximum or minimum point. This vertex is a maximum point because it's at the top of the parabola, and I knew the vertex was going to be a maximum point because of the negative in front of the square term. If there's a positive in front of the square term or a positive in front of a parentheses, it's a right side up parabola and the vertex is a minimum point. If there's a negative in front of the x squared term or a negative in front of the parentheses, it's an upside down parabola and the vertex is a maximum point. Because this is an upside down parabola, the vertex is a maximum point. And then we usually split up the vertex in this little sentence that I wrote down here to finish up the problem, to state the maximum or minimum value. I'll say the maximum y value is y equal to 5, which occurs when x equal to 0. If you look at the points that I have written, the highest y value is 5, or the maximum y value is 5, and there won't be a point that has a y less than 5. Two more parabola graphs, and then some word problems. So the next, or then a word problem. The next problem has the same instructions. Make a table of values, sketch a graph, identify the vertex, the axis of symmetry, state where the vertex is a maximum or minimum point, state the maximum or minimum y value. In this problem, because there's a positive in front of the parentheses and not a negative, the vertex is going to be a minimum point. If that 3 was a negative, the vertex is going to be a maximum point. In order to get my table, when these parentheses problems, I usually change the sign of the number inside the table. So I'm going to change the sign of -4, the number inside the parentheses, and I'm going to place +4 in the middle of my x column. So my x column has a +4 in the middle, and then I just went bigger and smaller. Bigger than 4, and stepping by 1 is 5 and 6, smaller than 4 is 3 and 2. So there's my table of x's. For each x, I can get a y in my calculator. I have the by handish work here, but I wouldn't do it by hand. To do this, to plug in 2 for x, I'd go 3 parentheses. Because the x is positive, I don't need a parentheses, so 3 times x, which is 2, minus 4, parentheses, x squared minus 6. That's how I would plug in the 2 in the x column on my calculator and get the y equal to 6. And then for 3, I can go 3 parentheses, 3 minus 4 squared minus 6. That's how I got the -3. If I want to, I could just back up using my cursor, hit the delete on the 3 and change it to 4 to get the y of -6. Similarly, if I didn't want to type everything again, I could just use my back arrow here, kind of this mouse key, get my cursor flashing right next to the number 4 that I want to change to 5, hit the delete key, type in 5, and hit equals. And so I can get all the points that way. And now my calculator or my program plotted the points for me. So plot the point 2, 6, plot the point 3, -3. Always, 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 when I graph parabolas, I make the vertex in the middle of my x column. And then plot the point 5, -3, and the point 6, 6. So, made my table of values, I sketched a graph of the function. Done with that, identify the vertex. The vertex is the point 5. The vertex is the point 4, -6. In this case, it's at the bottom of my parabola because of the positive in front of that 3. And then identify the axis of symmetry. I actually even graphed it here. The axis of symmetry is the vertical line that cuts the parabola into 2 equal halves. And an axis of symmetry always only has an x, and it's whatever the x coordinate of the vertex is. So the axis of symmetry here is going to be x equal to 4. So identified my vertex, my axis of symmetry. It's nice if you draw the axis of symmetry in, but it's not necessary. And then I say whether the vertex is a maximum or a minimum point. The vertex, because it's at the bottom of the parabola, is a minimum point. And then I split the vertex, the y coordinate of the vertex first, the x coordinate of the vertex second, and write this little sentence fragment. The minimum y value is y equal to -6, which occurs when x equal to 4. It's the same sentence as I had in the last one, except I had the word maximum as opposed to minimum. And that's everything for problem 13. The important thing is knowing how to get the table started. If there's a parentheses, you change the sign. If there's one x squared term like there was on 13, no parentheses and not an x to the first power term, you put a 0 in the middle of the x column. The last parabola graph we're going to do is problem 15, and the instructions are slightly different. It gives me the hint that I need to use the Vertex formula to find the starting point for my table. So when there isn't a parentheses, but there's both an x squared and an x term, I need to use the -b/2a formula to get the number for the middle of my x column, where a is the number in front of the square term, and b is the number in the front of the first power term. So a is -2 and b is 12. Just using the -b/2a formula, putting in 12 for b, I stuck the negative sign with it just because I needed the negative sign from out front to be somewheres, and the numerator is a nice place for it. So there's my negative b, and then 2a is 2 times negative 2. This comes out to negative 12 over negative 4, which is positive 3. I put positive 3 in the middle of my x column. Then I went bigger a couple and smaller a couple. And then for each x, I need to get a y. Super easy to do. I can go negative 2 times parentheses 1 squared, change that x to 1, plus 12 parentheses 1 minus 13. And that's going to give me the y that corresponds to the 1. That's negative 3. And I could just back up, get my cursor blinking to the right of the 1, hit delete, change that 1 to a 2, back up again, get my cursor blinking to the right of that 1, hit delete, and type in 2 to get that. And then if I want to get this 5, I can do the same thing. I could type the whole problem again, or I can just edit. It's easier just to edit. And so I can get all the y's that way. I did negative 3. I don't know why I didn't do positive 3. But anyways, you can get all the y's. They're not particularly hard to get. So I found, at least I didn't really find the vertex completely. I found the number for the middle of my x column, which is going to lead to my vertex after I finish up my table. Made my table of values, plotted all 5 points on my graph. I'm just going to blow up the vertex of 3, 5. That's the important point. So made my table of values, sketched a graph, actually plotted all 5 points, drew a parabola through them. And now I'm going to identify the vertex. The vertex is this point 3, 5. It's in the middle of my table. It's at the top of the parabola. And when I wrote my answer, I just said the vertex was 3, 5. I drew in the axis of symmetry. You don't have to draw it in, but I kind of like to draw it in. And the axis of symmetry always has an equation that only has an x, and it's the x coordinate of the vertex, because the axis of symmetry goes right through the vertex. Vertical lines only have an x in their equation, and in this case it's going to be x equal to 3. I knew ahead of time the vertex was going to be a maximum point because of the negative in front of the square term. If there was a positive in front of the square term, the vertex would be a minimum point. Because there's a negative in front of the square term, the vertex is a maximum point. And then I split the vertex of 3, 5 up into this little sentence fragment. The maximum y value is y equal to 5, which occurs when x equal to 3. And that's everything for that problem. We just have one word problem from the last section, section 6.4. I have a lot of the answers written on here. I'll try to talk through the answers and do the little bit of algebra that's necessary. So I get problem 16 talks about an object being launched, kind of goes up and down. It follows a parabolic path. And it says the object's height in meters after t seconds can be found by using that equation. First, it wants me to make a table of values and sketch a graph of this height of the object function. And because there's not a parentheses, I can't just change a sign. There's both a squared and a first power term. To get my table started, I'm going to use the negative b over 2a formula, where a is the number in front of the squared term, which is negative 8. B is the number in front of the first power term, which is 64. So to get the number for the middle of my x column, I'm going to do negative b, which is negative 64, over 2a, which is 2 times negative 8. Didn't leave myself a lot of room, so I'll do this on my calculator. So the number for the middle of my x column is going to be 4. And I'm going to get bigger and smaller. And now for each x, I'm going to get a y by using the function. So the first x I'm going to use is 2. I'm going to do negative 8 times 2 squared plus 64 times 2. And that's, I'm going to do negative 8 times 2 squared and get 96. And then I'm going to change the 2's to 3's and get 120. I'm about to get my vertex. Change the 3's to 4's and get 128. And then change the 4's to 5's, and I should get that repeat. My tables always repeat, and get 120. And I should get 96 for the last number in my y column when I change the letter to 6. So there's my table. I had my calculator sketch a graph, and I didn't label all the points. They're not going to really be necessary. But this is a reasonable graph. You could plot all 5 points for now, and that's going to be fine. So I made a table. Here's the points. I sketched a graph. What do the number on the x-axis represent? Well, this tells me, it says the function gives the height in meters. I mistakenly thought it said feet, so some of my answers down here need to be improved. Gives the height in meters after t seconds. The t, so this graph right here, the x-axis is the time in seconds axis, and the y-axis is the height in meters axis. So the numbers on the x-axis represent the time in seconds, or how long since the object is launched. So they're time. What do the numbers on the y vertical axis represent? Well, the x's are times, the y's are the h of t, and the h of t is the height in meters. So what do the numbers on the y-axis represent? It represents the object's height in meters. For some reason I wrote feet because I maybe didn't read it closely enough, or I read it and forgot. Identify the vertex. I have that already graphed. And then what do the coordinates of the vertex represent? Well, the 4 for the vertex is 4 seconds. The 128 for the vertex is it's 128 meters high. So the vertex says at 4 seconds, the object is 128 meters high. And I tried to write that here. The object will be 128 meters high 4 seconds after it was launched. And you can see by the path, when does it reach its maximum height and what is its maximum height? Its maximum height, because the vertex is a maximum point, is that 128 that occurs at 4 seconds. So this is where we get the vertex being a maximum or minimum value and having it be a big deal. Because the vertex is a maximum point, the maximum y value, which is a maximum height for this object, is 128 meters, and it occurs at 4 seconds. So for problem part F, when does it reach its maximum height? 4 seconds. What is its maximum height? 128 meters. And then H wants me to find the x-intercepts. I wrote the answer down here because I knew how to do it, but that I'm going to do by hand. So to find the x-intercepts, I should take the function and set it equal to 0. Technically, I'm not finding x-intercepts. I'm technically finding t-intercepts because the variable for the x-axis is t. That doesn't really matter. But to find the intercepts, I'm going to take the function, the right-hand side of the function anyways, and set it equal to 0. There's a common factor of t because both terms have a t, so I'm at least going to 1 parentheses factor to solve this by factoring out a t. If I notice that the first term is negative, I might also factor out a negative. And if even better, I notice that 64 and 8 are both divisible by 8, and 8 is the biggest number that divides into 8 and 64. Factoring out a negative 8t would be the best first step. And when I factor out a negative, I need to switch signs. When I factor out an 8, I need to divide by 8. When I factor out a t, I need to remove a t. So inside the parentheses, that negative sign is going to turn to an implied positive sign. This 8 I'll divide by 8 is going to turn to an implied 1. This t squared, I took 1 t out, I'll be left with a single t. I factored out a negative, so this plus sign is going to turn to minus. I factored out an 8, so I'll do 64 divided by 8 and be left with an 8 after the minus sign. I took the t out so I don't leave a variable with the 8. It's just plain 8. Now I'm going to, since I have it factored, I'm going to take the individual factors and set each one equal to 0. For the factor of negative 8t equal to 0, I'll divide both sides by negative 8. The left-hand side, the negative 8s will cancel, will leave me with a t. The right-hand side has a fraction with a 0 in the numerator, and fractions with zeros in the numerator reduce to 0. The t minus 8, I'll add 8 to both sides, and these will give me the x part of the x-intercepts. The x part of the x-intercepts are 0 and 8. And always when I'm finding an intercept, the opposite letter is 0. The opposite letter for an x-intercept is the y part's going to be 0. Again, maybe I'm kind of fudging up on the names a little bit. These are really t's and h of t's, but that's hardly that big of a deal. So find the x-intercepts using algebra. The x-intercepts are 0, 0, and 8, 0. I actually took the time. Those were the other points that I plotted. I actually plotted the x-intercepts because they're important-ish numbers. You don't have to have them identified on your graph, but I knew that I needed to explain some stuff about the domain and the range, and then the x-intercepts were going to be important. So that's part H. I know what the x-intercepts are. And now, for part I, give a physical interpretation. Well, you can tell this object starts at 0 meters high. It gets up to 128 meters high. It goes back down, and at 8 seconds, it's back down on the ground. This portion of the graph represents underground. This left portion of the graph is negative time beneath the Earth's surface. This is positive time, but beneath the Earth's surface. So the x-intercepts are basically when the object is on the ground. It's on the ground at 0 seconds, and it's on the ground at 8 seconds. And I wrote a sentence here. The object starts the ground at time equal to 0 seconds, and it lands after 8 seconds of flight. So last bit we have to get through is the practical domain and the practical range. So although I can plug in numbers bigger than 8 into this function, I can plug 10 into this function and get a value, but it's not going to make physical sense because the value that's going to come out is negative. So I can't really, it doesn't make sense in terms of what I get out. Plugging in negative numbers for time, you don't really have negative time. The time before this object launched, this doesn't make sense. The time after it hits the ground, it doesn't make sense. The practical domain is 0 to 8 seconds because it's only flying from 0 seconds to 8 seconds. After 8 seconds, its flight is over. Preceding 0 seconds, its flight hadn't started yet. So the practical domain is 0 to 8. And the practical range, well, this is the portion of the function the graph I'm looking at. The y's are the range parts, and at the y's are the heights of the object, and the lowest height it gets was 0 feet. The highest height it gets is 128 feet, 128 meters, should I say. And I wrote 0 to 128 for the practical range because the object doesn't go higher than 128 feet, and the graph, although the graph goes lower than 0 feet, 0 meters, the object can't go lower. The real range of this function is negative infinity to positive 128. If you remember from what we did a few chapters ago, finding the domain of a parabola, you might know that that's the real domain. But for practical purposes, because the object can't go underground, I guess, unless it's like a bomb and it can blow a hole, but for this purposes, we're going to assume that the object can't grow underground, so the minimum height is 0 meters, and the maximum height is a real maximum height of 128 meters. So that should be everything for our Chapter 6 test between the two parts that we did. So hopefully you're feeling okay about this. If not, let's get together and make sure it is okay because it's our last test of the semester.